Okay, in this tutorial, I'll try to solve question 1 as an example. So what we've got is a sample of clay that's been subjected inside the chamber of testing to 10 kPa of loading. Okay, so let me highlight this. 10 kPa. Okay, so we got 10 kPa. So when all movement of clay has stopped at this seeding pressure, the properties of the clay are obtained. So we have these properties and sigma PC as 50 kPa. So I can draw that. So we have applied. Okay, we have applied 10 kPa. When we did that, we have obtained the following properties. We've obtained void ratio, we obtained C sub C, and we obtained CR, and finally we obtained sigma dash PC 50 kPa. Okay, so the clay then is subjected to a two-stage test. The first stage, the pressure is increased to 100 kPa. So we could imagine that the pressure has increased to 100 kPa. Then the pressure has been reduced in stage 2 to 50 kPa. Okay, we've been asked to find the void ratio at the end of stage 1 and stage 2. To solve these problems, I always try to imagine what's actually happening inside the properties of soil. So we plot the void ratio. Okay, we plot the sorry, that did not come up right. I try to plot the void ratio log log stress. So first at stage 1, okay, we had the stress to be 10, log 10. I will just not write log, I'll just write now. Then we had 50 for sigma dash BC. Then we had 100, then back to 50. So what has happened? We've moved from 10 to 50. Let's just okay. Then 50 to 10. We found out that 50 is the pre-compression stress. So we expect the slope to vary at this point. Okay. So the slope of this line would be CR, and the slope of this one would be CC. So we had 10, then we exceeded 50 to 100. We cannot get to 100 directly down because we're passing through the pre-compression stress value. So we have to have a transit zone. We change from pre-compression to compression. Okay, then once we get to 100, which is stage 1, we went back and we reduced the load. We reduced the load to 50. Okay, that would be stage 2. We were asked to find the void ratio at this point and the void ratio at this point. Clear? So initially, to find this void ratio, to find this void ratio, E1, let's call it E1. Okay, we could find delta E stage 1, which is E1 minus E naught. Okay, E naught is given to us as 0.821, so if I find delta E, I can find E1. And so that's the deal. So we noticed that we've actually jumped from recompression to compression. So I could say now delta E1 is equal to the slope CR times log sigma dash PC over sigma dash node plus CC log sigma dash final over sigma dash node. You might be asking yourself, how did I come up with this formula? I'll show you in a minute. Okay, let's see that. Again, I will draw the graph. Sorry. So we could say this is E0, this is EP, then we want this point. This is E1. Okay, what are we finding? We're finding delta E1 first, which is this one, which could be simplified to EP minus E naught, or it's gonna be, let's call it delta E0 delta EP. So it's gonna be delta E0 plus delta EP. Now delta E0 is EP minus E naught, right? If I want to find this one, I have to use CR. Okay, so the slope CR, this is the slope of this line. CR is the change, which is delta EP E naught, over the change in the stress, which is sigma dash PC and sigma dash naught. Again, log minus log. Log minus log is log over log. It's the same thing. So I can say delta E naught is CR log. Okay. Next, I could say that delta EP is using this slope, which is CC slope. Okay, so I should say CC equal delta EP over log, this point is sigma final minus log sigma initial, which is log over log. Therefore, I can say sorry, that delta EP equal CC log sigma final over sigma PC. So now if I add this plus this, I get delta E1. Therefore, delta E1 equal CR log CC. Now we just need to substitute the numbers in. If you remember, CR was given as 0.07, CC 0.3, and sigma is 50. Sorry. So 0.07 log sigma PC 50 over sigma dash naught 10 plus CC, which is 0.3 log sigma final 100, and sigma PC is 50. Therefore delta A1 is 0.139. Okay, that is equal to E naught minus E1. Therefore, E at stage 1 equal to delta E1, or I could say actually equal to E naught minus delta E1. E naught is E naught given as 0.821 minus delta E, which is 0.139, gives us 0.682. So this is the void ratio at the end of stage 1. And the void ratio at the end of stage 2, we need to have a look at the graph. So if we look carefully, we could see that at the end of stage 2, what happens is that the stress reverses back. So we've reduced the stress, okay, to 50, which is here. So that's stage 2. So now we're moving from this point to this point. So we can see that we're moving along only one slope, which is CR, correct? So now I'll draw another graph. Okay, and that is CR. So now I can say that the difference in void ratio, difference in void ratio delta E2 equal to E1 minus E2. Okay, and I can say that CR, which is the slope, is the difference in void ratio over the difference in the stress, which is, I should say directly now, sigma final over sigma final 2 and final 1. Okay, so delta E2 now equal to CR log sigma final 2 is 50 over sigma final 1, which is 100, and CR is 0.07. It does not change. Finally, delta E2 equal to minus 0.021. So minus, that means the soil is actually going to expand, which makes sense, right? Because we've reduced the stress. That is equal to E1 minus E2. Therefore, E2 equal E1 plus 0.021. E1 was determined to be 0.682. Finally, we have the void ratio at end of stage 2 to be 0.703. Okay, and that's the end of the first example. Thank you.